Hi, everybody. Let's do IXL 7th grade J7. Go to Learning, go to, make sure you're on Math, then go to 7th grade J7, Scale Drawings, Word Problems. All right, so before we do that, let's look at Frydman Math. And scale drawings is on page 6. So we can scroll down to page 6. And scale drawings is right over here. I'm not going to read this entire thing right now, but I'll jump back to it as we do the exercises. But over here we have scale factor, we have unit scale, we have converting units, the multiplication strategy, converting units, the proportion strategy, and then we have a little bit of explanation of when finding area, you need to convert the length and the width. We're not going to be using this one for this exercise. So let's just go ahead and look at the first question. Alana drew a scale drawing of a neighborhood park. In real life, the volleyball court is 16 meters long. It is 8 centimeters long in the drawing. What scale did Alana use for the drawing? So going back to the reference page here, we are looking for the unit scale. Oh, I forgot to mention that IXL is put this 1 over here. So we are looking for the unit scale since the 1 is there. And the way that we're going to do that is pretty simple, actually. We're just going to write the numbers down and then divide by one of these numbers such that the units that we want to be a 1 turn into a 1. So for example, over here, we want the units of centimeters to have a 1 in front. So first what we're going to do is write down the 8 centimeters and 16 meters. So let's write that. We have 8 centimeters corresponds to 16 meters, and we want the 1 to be in front of centimeters. So that means since we have centimeters over here, that means we're going to have to divide by 8, because then we would get a 1 here. So then we have the 1 along with the centimeters, which is what we want. But if we divide this side by 8, we're going to have to divide this side by 8 also. And so we will get over there, 16 divided by 8 is 2. So we have 2 meters. Right? That's it. Nicole made a scale drawing of a house and its lot. The scale she used was 1 inch to 2 feet. If the actual width of the porch is 16 feet, how wide is the porch in the drawing? So for this one, we are going to be converting units. And we can use either the multiplication strategy or the proportion strategy. In this video, I'm just going to use the proportion strategy. So we're just setting up a proportion and then we're cross-multiplying and solving. So let's go ahead and do that. We're going to use the numbers that IXL gave us over here to start our proportion. So we have, let's write 1 inch over 2 feet equals, now the other number we were given was 16 feet. So since I have feet here, I want to put feet over here. And since I have inches over here, I want to put inches over here. And this, again, this 16 was 16 feet. So that should go over here next to the feet symbol. And up here in the numerator, we'll put an x. That's what we're looking for. And then we'll just, we could cross multiply. Well, actually, for this one, we could say that 2 divided by 2 is 1, and 16 divided by 2 is 8. So that's one way that we could have answered that question. So the answer is 8. There's more than one way that we can do this. You could have also done, let's put the x back over here. Could have also said, aha, 2 times 8 is 16. And if we do the same thing in the numerator, 1 times 8 is 8. So that's another way that we could have gotten an 8. And there's one last way that we could have gotten an 8. And that's actually to do what was written over here on the reference page, which was to cross multiply and solve. So if we do that, we have 1 times 16 is 16. Don't forget the equal sign. 2 times 8 is, whoops, my mistake. That was not supposed to be an 8, was it? That was supposed to be an x. All right, so we have 2 times x is 2x. And then we want to get the x by itself. So this is 2 times x. The inverse of multiplication is division. So we will divide both sides by 2. Cancels over there, and we get x equals 8. So that's another way that we could have figured it out. But anyway, that's our answer, 8 inches. So if 1 inch corresponds to 2 feet, then 16 feet would correspond to 8 inches. Let's hit submit. Joel drew a scale drawing of an arcade. He used the scale 1 inch to 5 feet. The actual length of an air hockey table is 10 feet. How long is the air hockey table in the drawing? So once again, we'll use those numbers over there. And to start our proportion, then equals, I have inches in the numerator, feet in the denominator. Here I have 10 feet, so that goes over here next to feet. And I know that 5 times 2 is 10, so if I do the same thing in the numerator, 1 times 2 is 2. So the answer there will be 2. Okay, this looks to be the same type of question, so let's go ahead and skip to the next level. Caden drew a scale drawing of the middle school. In real life, the gym is 44 feet wide. It is 22 inches wide in the drawing. What scale did Caden use for the drawing? 1 inch corresponds to how many feet? So once again, this is a problem over here, like this one over here, where we're looking for the unit scale. So we need to write the numbers out, and then we need to divide. And we have to divide strategically so that we get the 1 next to the units that we actually want it next to. So we have, let's just write everything the same way that it is over here. So we have inches on the left. IXL is giving us inches on the left and feet on the right. So let's just continue that. It'll make things a lot easier if we do it the same way. So let's write 22 inches on the left, and on the right, we'll put 44 feet. Okay, now we want the 1 to be next to inches. So here I have inches. I want to divide this by some number that'll give me 1, and that number is 22. If I divide anything by itself, then I get 1. So I get 1 inch over here, which is what I wanted, and I need to divide the right side by the same thing that I divided the left side by. So we have 44 divided by 22 is 2. So we get 2 feet on the right. So there's our answer. We'll put a 2 right over here. And that's that. This question seems to be the same type of question as this one. So this is another converting units question. We already did that, so I'm going to skip to the next level. These might all be the same, actually. So let's see. Okay, this one's a little bit different. Dylan drew a scale drawing of the elementary school. In real life, the schoolyard is 171 meters long. It is 342 meters long in the drawing. What scale did Dylan use? Now this time, instead of getting a 1 over here, we want a 2. So it's actually basically the same as this, but instead of ending up with a 1, we want to divide in a strategic way so that we end up with a 2 next to millimeters. So let's see if we can do that. Let's see, IXL gave us millimeters on the left, so let's put millimeters first. We have 342 millimeters on the left, and on the right we have 171 meters. Okay, now we have to think to ourselves, 342 divided by what number is equal to 2? Okay, 342 divided by what is equal to 2? Now, how are we going to figure that out? Well, here's something interesting. Let me use some other numbers just to show you something for a second. So, for example, let me use the numbers, I don't know, 24 divided by 4 is equal to 6, right? Now, what about 24 divided by 6? What is that equal to? Well, that is equal to 4. So if I have a number, let's say a number A divided by, let's call this B, is equal to C. So if A divided by B is equal to C, then A divided by C is equal to B. In other words, I can take this number and this number and switch them around and still get a true statement. All right, now that is not the commutative property. The commutative property would say that I could switch this number and this number around and still get the same answer, which is actually not true for division. But with division, I can switch this number and get the same answer. Now, how does that help us with this problem that we have over here? Well, what am I looking for? I want to know 342 divided by what number is equal to 2. Well, I can write a sentence that goes along, that sort of corresponds to this sentence, and I can say that 342 divided by 2 is equal to x. In other words, if I take 342 and divide it by 2, then that will give me the number that, when divided into 342, gives me 2. So really, in order to figure out what goes here, we could just take 342 and divide it by 2. So Let's do that. 342, and that should be, I think, 171, right? Divided by 2 equals 171. Yeah. So if I know that this is 171, if I know that 342 divided by 2 is equal to 171, then it must also be true that 342 divided by 171 is equal to 2. So if I want this 2 here, that means I should take 342 and divide it by 171 to get that 2. And we can just check that in the calculator very easily. 342 divided by 171 is actually equal to 2. So that works. So now we know that we should be dividing both sides actually by 171. So on this side, I would, oh, I forgot to write meters in here, by the way. So on this side, I would get 1 meter because 171 divided by 171 is 1. Okay? Keep in mind, I'm not dividing by 171 here because there's 171 over here. That was just a coincidence. I'm dividing by 171 over here because that is the number that I needed to divide 342 by in order to get 2, which is the number that I wanted because IXL told me to over here. All right. So this number turns out to be 1. There. Okay, so if 342 millimeters corresponds to 171 meters, then 2 millimeters corresponds to 1 meter. Right? This is twice as much as this, and this is also twice as much as this, so it seems reasonable. All right. Okay, so we have another, this problem would be a converting units problem. I think all the problems that it's going to give me after this will be similar to the ones we've already done. What the hey, I'll do it anyway. So so we have here 9 inches over 4 feet. Let's just do it quickly to get to the next problem. Equals, let's see, feet here, inches here. I have 8 feet, so I need to put that next to here. I'm looking for inches in the numerator. Well, this one's not too hard because it gave me nice numbers. So I know that 4 times 2 is 8. So if I do 9 times 2, that would be 18. So let's type in 18 there, and let's see if the next question is any different. No, it looks like all these other questions are the same. This one, you just have to be careful. I'll write it out for this one. We have 8 inches over 3 feet equals, notice that I put inches in the numerator here, so I need inches in the numerator here, feet in the denominator, so I'll put feet in the denominator on the other side. The only little twist here is that it gave me 16 inches. So in all of the other questions that we did, solving a proportion, that other number went in the denominator, but that does not always have to happen. You see here, I put inches in the numerator, and this is inches, so I would have to put inches in the numerator over here also, and x in the denominator. And then I know that 8 times 2 is 16, so 3 times 2 would give me 6. So that's that. Right? I'll do one more question like this because I know a question like this is kind of tricky. Again, it's very similar to this question over here, except you have to make sure that the number that you're dividing by gives you, in this case, a 2. So let's do that. We're going to, let's see, we have inches on the left, we have feet on the right. Let's just keep it that way because it'll be easier. So I want 4 inches on the left, and I want 2 feet on the right. And I want to divide the inches so that I get 2 inches over here. So what do I have to divide 4 by in order to get 2? Well, the answer is 2. 4 divided by 2 is 2. And you could also have figured that out by doing this number divided by this number. 4 divided by 2, which gives you 2. Okay, and then divide the other side by 2. That will give us a 1 over here because 2 divided by 2 is 1. So we get 1 foot over there. Okay, so same type of question over here. This would be a converting units problem. I've already done a few of those. You could try it using the multiplication strategy if you want to read through this and then give it a shot using that strategy. You could do that. But I'm going to leave it there. So I hope that was helpful. Reach out if you have any questions, and have a great day.